On page 8, we have a question: how much energy is it going to take to convert 600 milliliters of water at 40 degrees Celsius to ice at 0 degrees Celsius? And I think the easiest way is to draw a picture to get a look at what we're going to do. Now, notice we're going from water to ice, so instead of absorbing energy, we're going to be releasing energy. So I'm just going to draw the whole plateau and the whole guide thing here. Start with the gas. If it gets to 100, it would condense, it would plateau out. Then it would be a liquid between 100 and 0. And then at 0 degrees, it would freeze. And then once it's frozen, it would keep cooling down like that. Now, we're trying to isolate where we're starting. And we're starting at point A, which is water at 40 degrees Celsius. And we're trying to end up at 0 degrees Celsius. Do we want water at 0 degrees Celsius, which would be point B, or ice at 0 degrees Celsius, which would be point C? We want point C. We're assuming it all freezes, but we're catching it before the temperature starts to drop back again. So temperature on the vertical axis, horizontal axis, we're just removing heat energy steadily as we go. All right, let's solve the problem. It looks like we have A to B is going to be a slope formula, B to C is a plateau formula. So once you get that picture and know what you need to do, that's probably the most important part. Okay, so going from A to B is CM triangle T. Liquid water, the heat capacity is 1 calorie per gram degree Celsius. 600 milliliters of water would be 600 grams. And you're going from 40 to 0, which would be a change of 40 degrees. You multiply those through, you get 24,000. Remember, that's calories. And then divide by 1,000 to get to kilocalories. The other one we're going to look at is going from point B to C, which is the plateau. And I'm going to take N times delta HF. N is my number of moles, which I get by taking 600 milliliters, which is 600 grams, divided by the molar mass of water, which is 18, which gives me 33.3 moles. And then I multiply it by delta HF, which is 1.44 kcals per mole. Remember, you get that from your guide sheet on page 2. And I ultimately end up with 48.0 kcals. Notice that's in kcals right there. So from A to B, it was 24 kcals. From B to C, it was 48 kcals. If I add those up, the total is 72 kcals, and that would be released. So the next part of the question is freezing an endothermic or exothermic process. It's exothermic. Energy is released to the surroundings. So that's a little confusing to note why when something freezes is giving off energy, but think of the opposite. It does take energy to melt something, so it must be releasing energy as it freezes something.